So in this video, we're looking at relations and functions. You encounter functions each and every day. Look at these examples. In the first picture, I have to put coal in to get electricity out. I have to put money into the Coke machine to get a drink out. I have to put gas in my car for my car to run. I have to put wood in the fireplace for there to be heat. These are all representations of functions. They're rules. There's ways that things have to be done in order for something else to happen. So we're going to talk about relations and functions, but the first thing we're going to look at is an ordered pair, because that's where it all begins, is with the ordered pair. When I'm dealing with an ordered pair, and all of you are familiar with an ordered pair, if I gave you the ordered pair 3, 4, the ordered pair consists of an x and a y coordinate. The first number is my x coordinate or my x value. But the thing that you have to know now is it's not just an x and a y coordinate. It has other names, and you're going to be referring to those by these other names throughout the entire year from now on. Any math class, they might say, what is the input? They might say, what is the domain? What is the independent variable? And in each case, each question all represents the same thing. It represents this 3. It represents the x coordinate of your ordered pair. Your y coordinate also has multiple names. It's the y coordinate or the y value. It's the output. It's the range. It's the dependent variable. This 4 depends on this 3, and you're going to find out why as we go through. In the ordered pair, it consists of an x and a y coordinate, but that x and y coordinate has multiple names, and you need to be familiar with those names. A relation is a set of ordered pairs. So we've got an ordered pair. Now we've got a set, and a set simply means multiple. We've got more than one ordered pair. The domain, we already said, is the x coordinate. The range, we said, is the y coordinate. So when we're looking at a relation, it can be viewed in different formats as well. We can look at ordered pairs as a relation. We can look at a mapping as a relation. We can look at a table as a relation, an equation, a graph, or written sentences. When writing the domain and range, that's the x and the y coordinates of your relation, you do not repeat values. I'll explain that in the next slide. So if I gave you this relation right here, 2, -6 is an ordered pair. 1, 4 is an ordered pair. 2, 4 is an ordered pair. So I have multiple ordered pairs. I have a relation. If I asked you to state the domain, I would be asking you to tell me all of the x coordinates, all of the x values. However, you notice that some of the x values are repeating themselves. I've got a 2 and a 2. I've got a 1 and a 1. Whenever I list them in my domain as my domain, I do not repeat. So you notice I have, starting at the smallest number to the largest, I have a 0. I have a 1 and only 1. I have a 2 and only 1, 2, and I have a 3. I do not repeat, even though there are 2 2s sitting here. When I list my domain, my x coordinates, I do not repeat. The same is true for my y coordinates, my range. I've got a -6, a -4, a 4, a 0, a -6, and a 0. And once again, you notice that 0 repeated, and you notice that -6 repeated, and you notice that 4 repeated. So whenever I go to list them, again, I'm going to start with my smallest number, which was -6. I only write it one time. I only write 0 one time. I only write 4 one time. So when writing your domain and range, you do not repeat. Do not repeat. When looking at a table is simply a set of ordered pairs. It's another way of writing 3, 4. Here's 3, 4 as an ordered pair. Here's 3, 4 in a table. Here's 7, 2 as an ordered pair. Here's 7, 2 as a table. This table is written vertically. You can make a table that's horizontal. It does not change anything. X is on top, Y is on bottom, and I would write it like this. There would be my 3, 4, there would be 7, 2. So your table can go either direction. That does not have any bearing on the fact that it's a table. Then we have the mapping. And in a mapping, it's simply two ovals. The first oval, again, represents your x value. The second oval represents your y coordinate, your output, your range, your dependent variable. So again, I've got a 2 in my x. I've got a 1 in my x. I've got a 2. I've got a 0, a 1, a 3. And once again, you notice I did not repeat my 2. I only wrote it once. I did not repeat my 1. I only wrote it once. Same way with my y. I've got a -6, a 4, a 0, a -6, a 0, and I did not write them twice. Now, here's what's the thing about a map. A map is just like what you would see on any kind of map. It's going to draw arrows to show you direction. So my first ordered pair was 2, -6. So here's my 2, and I'm going to take my arrow, and I'm going to draw to -6. That tells me I have the ordered pair 2, -6. 1, 4. I'm going to take my arrow and I'm going to draw from 1 to 4. That tells me I have the ordered pair 1, 4. 2, 4. I'm going to take my arrow from 2 and go down to 4 and so forth. So your arrows are what are indicating your ordered pairs. And I can tell right now, well, let's just move on. I'm going to come back to that in just a moment. So is a relation a function? Remember we said we're talking about relations and functions. We've determined that a relation is simply a set of ordered pairs. A function, according to the textbook, is a relation in which every input is paired with exactly one output. It's a rule. A function is a rule. Just like the Coke machine. Let's go back to that. If I put my dollar bill into the Coke machine and I push Coca-Cola, what should fall out? A Coke. But if I put another dollar bill in and I push Coca-Cola and out falls a Dr. Pepper, the Coke machine is not functioning correctly. A function must follow a rule, and the rule would be every time I put a dollar bill in and I push Coke, a Coke should fall out. So a function is simply a rule where every input, every x value, is paired with exactly one output. In other words, let me scroll down here. In other words, my x coordinate is set to have different x coordinates. It's a function. When my x coordinates are all different, it is a function. But if my x coordinates happen to be the same, and we did some examples where they were the same, it is not a function. In other words, let me put it very simply. If x repeats, it is not a function. If the x value is repeating, it is not a function. Now, y, nobody cares about y. He has no bearing in determining if something is a function or not. We're only concerned with our x coordinates. If x repeats, it is not a function. If x does not repeat, yes, it is a function. So let's take a look at some examples. Do these ordered pairs represent a function? These ordered pairs represent a relation. They are a relation because they are a set of ordered pairs, but are they a function? And the answer would be no, because I have a 3 here and a 3 here. They did not give me the same thing. There's my Coca-Cola, but here's my Dr. Pepper. So they did not follow a rule. The x value repeated, so it is not a function. Take a look at this one. My x value is a 4. My x value is a 5. My x value is a 8. My x value is a 9. My x value did not repeat, so yes, it is a function. Yes, it is a function. Is this mapping a function? This mapping is a relation because it's set up of ordered pairs. But is it a function? Well, my 3 goes straight to a -1. My 1 goes to a 2, and my 0 goes to a 2. Remember, my y can repeat. We don't care about y. We're only looking at x, and the x value did not repeat. So yes, it is a function. Over here at this one, I've got a 2 to 2, but I've got a -1 that goes to a 3 and a -1 that goes to a -2. It's repeating. That -1 is written twice. Again, back to my Dr. Pepper and my Coca-Cola. I put my dollar bill in, I get a Coke. I put my dollar bill in, I get a Dr. Pepper. It is not functioning correctly. It is not a function. No. Leads us to, how do I tell about a graph? When I'm looking at a graph, I have a little test that I can do with my pencil. And it's called the vertical line test, or AKA the pencil test. And what I do is I put my pencil on my graph vertically. Let me make sure you understand vertical. This is vertical, up and down. Here's my pencil. And I'm going to scroll it across the graph from left to right. Let's take a look at an example. Here's my pencil. I'm going to scroll it across this graph, and I'll just draw as we're doing it. Here's my pencil, it's scrolling. Here's my pencil, it's scrolling. And as I cross that blue line right there, do I ever touch more than one point at a time? No, there's a point, there's a point. I'm never touching more than one point on this blue line. So yes, it is a function. That's what the pencil test tells me. But when I look at this one, I'm touching a point here and I'm touching a point here. If I draw another line, I'm touching a point here and I'm touching a point here. So no, it is not a function. All lines represent a function except the vertical line. A horizontal line would pass the vertical line test. Here's the vertical line test. Yes, I'm touching one point at a given time. A slanted line, whether it's positive or negative, a slanted line passes the vertical line test. It's a function. But a vertical line, I'm touching every point on the line. It does not. So this is not a function. No, it's not a function. A horizontal line is a function. A slanted line is a function, but a vertical line is not a function. It does not pass the vertical line test. So to recap, an ordered pair consists of an x and y coordinate. It has multiple names. The x is the input, the domain, the independent variable, or x coordinate. The y is the output, the range, the dependent variable. A relation is simply a set of ordered pairs. Any set of ordered pairs is a relation. However, to be a function, it has to follow a rule. A relation in which every input is paired with exactly one output. And when we follow a rule looks like this. Y is equal to 3x plus 1. This is my rule. It looks like an equation, but all it is a rule. We use a table, a mapping, a graph, an equation, or written sentence to represent a relation or a function. The vertical line test is used to determine if a graph is a function, and all lines are functions except the vertical line. So make sure you have your notes, and we'll finish discussing this when we get to class.